back to my YouTube channel. And today we'll be designing a TinyURL. So this is a very famous question which has been asked in most of the product-based companies like Amazon, Microsoft, Walmart. Uh, if it can be asked by the name of a URL shortener. So yeah, this is a very famous and very good problem to solve. Let's see how can we solve this problem if you get it in an interview. So yeah, starting with our functional and non-functional requirements. First of all, what are the requirements? So yeah, as we know, we have to design a system where if we give a URL, it give us the shortened form of that URL, and if we try to access that shortened form, we are redirected to the URL which we all gave at first place. And yes, should handle a high traffic, and we are considering like if we will be getting requests to create 100 million short URLs per day for nearly 100 years. So we have to create a system with this much consideration. And for non-functional requirements yet, it should be highly available and it should be low latency to create the URL and also to redirect to the original URL. It should handle millions of traffic, uh, always available, and your fault tolerant as well. So yes, let's start. What and how can we do this? So starting with what size of URL we want to shorten. Like uh, uh, in a URL, there are two parts. So if we see that what we can do here is uh, so in every URL you see there is two part. First is the host, and then there is some text. Okay. So if we want to shorten URL, we need a smaller host, and plus this text should be shortened. For example, if you say like tinyurl.com/123, and we want to this should redirect to maybe Facebook. Okay, so let's suppose we have given a request of facebook.com. We want to shorten this facebook.com URL. So what we can do is we will obviously give this as a request, and in response we will get this. So as soon as we hit this tinyurl/123, it will be redirected to facebook.com. Now this is the host. Okay, first part, this will never change, but this is the unique hash value of our URL. So what size of this should be? Before starting this, what is the use case for which TinyURLs is used? So the main basic use case is like when we want to send SMS notifications, and SMS notifications always works on the cost depends on the number of characters you are sending in that SMS. Okay, so usually people want to send as small URLs as possible so that our cost is very less. So based on that, we'll see that what is the smallest size which can fulfill our requirement. Okay, so since our throughput is 100 million per day and there are 365 days, and for nearly 100 years, it will be creating 3.6k billion of URLs, nearly this much. Okay, so if we want to handle this, what we need to do? What we can do is we can pick the characters small a to z and capital A to Z and digits 0 to 9. So these are 62 characters, and if we pick these characters in a length of 7, so we will be getting nearly 3.5k billion records, which is nearly equal to our requirement. So I think 7 character URL is will be more than enough for us for right now. Okay, so yeah, so now we have decided what will be our size. Let's see how we can design it. Again, starting with our basic design, we have our system which will hit our server and will save data in DynamoDB. Why we have picked DynamoDB here? So DynamoDB is a key value pair and it is optimized for fast read and fast writes, and it is also highly available. We don't really need consistency here, so that is why we have picked this NoSQL DB. I will be creating a separate video of how DynamoDB is can handle such high number of reads and high number of writes, and how it is highly available. So I have created a playlist of HLD concepts where I'll be picking this topic up. So yeah, stay tuned on that playlist too. Yeah, so now what all APIs will be having? One is the create API. Okay, so we'll give our original URL and it will return us the tiny URL. And as soon as we hit that tiny URL, which comprises of our host and ID, it will redirect to the main original URL. So these two APIs are there. But is this that scalable? I don't think so. We have to scale a bit this. So what for scaling, what we can do is, since DynamoDB works on multi-node, or you can say master-master architecture. Don't worry, I'll explain this what master-master is in my separate video. You will get to know and how it works. Okay. So let's suppose for master-master currently you can say that each node, there are multiple nodes or multiple replicas of our DB, and each node has context of other nodes. Okay, so yeah, so for we'll be adding some load balancer in our service, multiple instance of the particular server, and yeah, cache node, because we always don't want to hit our database for getting the most frequent hit URLs. Okay, so we cache node is a must. So I think this designs look fine. Now we'll see how we can save this ID and value. So first approach here is we can use a hash function to generate a hash value of 7 digits, or you can say 7 characters of all the character values which we have seen. So what we'll do is we create a hash value and we'll hit the DB to see if that is already present. And here by this we are seeing that if there is a collision. If no, we'll save that key and the tiny URL and the value part in the DB and stop. If yes, if there is that value key is already present, we'll again create a new hash key and this process will repeat. This is good approach, but it is not very scalable, and it will also take a lot of time, because every time it is hitting a database to first see that it is present or not, which is I think is not a good approach. It will also increase our IOPS and reads, which will be a bottleneck going forward, and we cannot scale it much in this approach. So what else we can do? Maybe we can take UUID. If you're not aware of UUID, UUID are the IDs which are generated. It is 128-bit ID, and collision of this ID is very very rare. Okay, so I think we can rely on this ID, but again, this ID is too long for us to become our key, because we have to only have 7 characters so that we can make URL as short and as possible. So again, this UUID approach will also not work. Now what else? What else? As we have already seen that there are 62 characters which we can have. So what about 62-bit conversions? Base 62. So it will work something like that. If you have ID 0, so it will give you uh, value as 0, and for having 7 characters consistent, we have added 6 hash. So we can add these prefix uh, so that all the keys have same number of characters. All the every keys have same number of characters. So like yeah, so for 9 it is 9, for 10 it will become a small a, and for 35 it will become small z. For 36 it will be capital A, and for 61th ID it will be capital Z. So like this, we can convert it our IDs into our keys which we want. But what about this ID? From where we will get this ID? So yeah, in this topic, I will also covering uh, how to generate unique IDs. Okay, so as you can see, if we get this ID somehow, we are getting the value which we want of 7 characters, and our design is good. We are ready to go with this design. So yeah, a tiny URL service is designed, but now comes the problem: how we'll get that ID. That is a separate problem, which we'll covering in this video only. Don't worry, I'll let you know how to design, how to generate this unique IDs every time. So there are multiple approaches to do this for unique ID generator. First is we can create one server which is responsible for generating unique ID, and all the instance of our TinyURL servers will hit this server to generate a unique ID, and it will return that ID. So this is good approach, but again, this is a single point of failure. If this ID generator is gone, all our server will go down. So we will not be able to handle that traffic. So if we are using this ID generator, it will our most optimal design will look like this, which is good but not that scalable and fault tolerance which we want in our non-functional requirement. So yeah, our non-functional requirements are not getting fulfilled here. So yeah, we cannot use this. So what else? There is one more approach which is quite complex, but it is highly effective. So yeah, what we can do is for every instance of our API server, we can hit a load balancer or mapping service, which will have a different ID generators. Okay, so this ID generator, so which server has to hit which ID generator will be decided by this mapping service and load balancer. So what we'll do is we'll assign one ID generator to each of the instance. Okay, so we'll take care of that every instance of that server hitting that ID generator instance only by this mapping service. Like this, I think if one ID generator goes down, this can assign it to another ID generator, and I think it will fulfill our approach. It will fulfill our needs, and this approach will be the most optimized way. But how, what is the difference between this one and this one? How we are able to scale this? What is the logic behind it? How this ID generator will give us the IDs? So as we know that maximum ID which can be generated is around 3.5k billion. So what if we calculate these IDs on in the start only? Like if we give responsibility of different ID generators, like this ID generator will give values from 1 to 1 lakh only. Okay, so it will maintain a queue, and each time one request will come, one ID will be popped out from here. Like first request come, one will be popped out. Now two will be popped out, then three will be popped out. Like this ID generator is popping out values from its range. As soon as this queue is empty, our load balancer will know that which ID generated instance queues is empty, so it will stop sending requests to that ID generator. And how will this mapping service or load balancer will know that which ID generator's queue is empty? So for this, what we can do is we can maybe ping, maybe create a cron like this. This what this cron will do is it will hit all the ID generator one by one and see if it is empty or not and update and tell the mapping service. So this is what pinging is. So we'll ping that ID generator. What is your length left? Okay, one by one. Maybe we can also this load balancer knows what all active uh, ID generators are there which are serving. So maybe for that only this cron can tell that it is finished or not. Like that also we can optimize this. So if in a broader way, we'll see that this cron is responsible for hitting all the ID generators and letting this our mapping server know that which ID generator is not currently serving any IDs, or its IDs are exhausted. Okay. So like this, we can have multiple. We can increase this range so that our number of ID generator instances are less. So we can that configure that. So like this, we can have n ID generators, which will give us 3.5k billion of IDs. As soon as we get the IDs from this, so now see ID, we have the ID generator. The server will convert that ID generator uh, into our value in hash, or you can say we can into our hash key, and based on that hash key, we'll save data into key value pair like this. ID will key and value will remain URL. So as soon as we'll get that hit, so we will check that against that key what is the value, and we will redirect that request to that value. Yeah, I think this is the most optimal and most optimized way to design a URL shortener. And yes, uh, if you give this solution in an interview, 100% will be selected. Yeah, that's it from this video. Do let me know how did you like this video, and also please like, share and subscribe my channel, and let me know in the comment section what all designs you want to know and what all concepts you want to know of high level design. I'll come up with the video as soon as possible. Till then, take care, man.